Hello, and thank you for joining today's live action webinar, How to Bridge Visibility Gaps from the Network to the Cloud. I'm Monique Lucy, Director of Product Marketing here at LiveAction, and I will be your host for today. And I'm thrilled to be joined today by John Smith, founder and CTO here at LiveAction. He will walk you through the demo in just a moment. Please feel free to ask questions during the session using the Q&A panel on the right. And this session is being recorded, and you'll be receiving an email with a link to the playback after the event. And we've also shared some additional resources that you may find useful, and you can find these by clicking the Attachments tab. And with that, I'm going to turn it over to John for the demonstration.
Thank you for joining our webinar. We're going to be talking about cloud monitoring best practices, and specifically we'll be talking about how to get visibility on premises and into the cloud in a single platform, and use cases related to application performance, but also how do you get visibility down to the packet level for application performance, but also for security incident response. So the context for this webinar is really looking at this demo system that we have. And it actually has various sites connected together, and also from on-premises connects to various cloud service providers. And in this demo, we're going to be looking more closely at the Amazon portion here as well. So we'll focus more on that. So just even from this view, you can see, on-premises, and we can show all the flow information coming from the various data centers and sites into AWS regions. So we'll be delving further into that. And if you have other cloud service providers like Azure, we could do that as well. So just getting visibility into one platform is actually very important. And another key aspect of this is looking at cloud network abstractions like VPCs and how to represent that so it's understandable from a networking perspective. So this is a VPC, and we can show all the different interfaces that are connected to various subnets, for example. So VPN gateway or IGW, and how does the traffic come from on-premises or from various users or customers work from home back into Amazon and then to other EC2 and other services. So being able to map that is actually very important. And on the left-hand side, you'll see the LiveWire. So this is our packet analytics capability. So for deeper performance information, troubleshooting applications, or security incident response, being able to mirror that traffic into our LiveWire packet analytics to do analytics and performance analysis is very important. So let me switch to a more high-level view, and we'll get started here. So here we can show all the different sites, including our AWS Oregon site here, and we can show it in context of their various status. And from here, we can dig further into, for example, Oregon and see what's happening here. But let me just flip this to a logical view. So this is good from a geographical perspective, but if I wanted to look at it from a logical view, I can show it using this view so that you can see the routers and different flows, and also on the AWS side, the various traffic. And we can look at it from an application perspective or DSCP marking, and we can drill down further into this. And we'll go through a couple of examples of this during the demo as well. And just back to the geographical view, if you're troubleshooting something here and you wanted to dig deeper into Oregon, for example, you can click this, and we can see into Oregon. So whether you're doing on-premises or cloud, we'll show a very simple topology view on the right-hand side with the VPCs or other devices, including things like NFVs or virtual router instances that you might be running in the cloud. They'll show up on the right-hand side, and we can pull information from that, but we can also get flow information as well. So just digging a little bit further into this. So this is a VPC that exists in AWS. And like I mentioned, we use cloud native telemetry to understand what's happening in this VPC. So if I look further into this VPC, we can look at the actual flows that are going through this. So you'll notice that it's flow log, but it looks very similar to IPFix, for example. But we use not just the flow log through APIs from AWS to grab this information, but we also provide the context of this. So for example, here's a Docker application, and we know the service that it's being generated from is AWS EC2. We know which region and specifically which zone, so 2A, which protocol, the source and destination IP addresses. And if you have DNS enabled, we can resolve these as well, in bytes and out bytes. But we also know things like the eventing. So for example, this is a flow denied, and then there's flow created. So when we do the security portion of the demo, this will become more interesting, where we look at security group policies and looking at flow logs to understand what's getting rejected or what's getting allowed. But there's a lot of context from the flow log that we can leverage and provide more information as well. And the other portion of this is looking at the AWS LiveWire capability. So just looking further into the LiveWire. So this is our packet analytics. So it can generate metadata, IPFix information as well. And you can look at the various data. But the interesting thing is, and we'll go into more in depth in the latter portion of the demo, but you can go into the packet level. So if you click on this peek button here, you can actually do a forensic search of all the packet capture that is being captured in AWS that's getting mirrored. And you can enter a specific filter or different types of data that you want to see. And we can start capturing. And then from here, we can look at that set of captures and look at it from a networking perspective. So these are the network traffic, all the application response time, and we'll go into more detail on this when we do the application performance portion. So just a quick overview initially of the demo that we'll be doing a webinar on. So going back to the geographical view, we want to look at things from an application performance perspective. So right now we see AWS Oregon, and there's some active alerts. So there's some delay happening on our Mongo database. So we can investigate this a little bit further. We could click on the Oregon site and bring up more information here. And sure enough, there is a warning. It's an active alert. And there's some application performance happening here. And it highlights on the right-hand side in the topology view. And we can drill further into this to find out more detail. So I'm going to click on this description. And it'll bring up specifically that particular alert. It'll tell you what the conversation is, the source site of that application. And then the destination site is actually in the cloud. So this is debugging on-premises apps talking to cloud. Give you some preliminary information as well. But we can go further into this, into more detail at the packet level, since we do have the LiveWire in AWS generating this. So I'm going to hit the peak. And it's going to ask us to pick multiple devices. If you had a chain of packet analytics devices, you can pick and select which one we want to see. But we want to see the one that's in Amazon. So we're going to click on the peak. And it'll fill in all the different parameters that we're interested in. And then we could do the search for this. And then this is the specific application that's causing the alert. And it'll show you the packets related to that. So we can see the source, destination, TCP, network utilization, application utilization, and some response time as well. And we can go all the way down to the packet level as well. So it'll pick up the packet conversation. And you'll notice on the right-hand side, it'll do an expert analysis. So it'll tell you things like, there's a TCP retransmission that's happening, duplicate ACK, too many retransmissions. So it has a lot of built-in expert analysis. So for that particular conversation that's causing the issue, you can kind of see in more detail what's happening. And we can look at this from a client-server perspective. You can see the different ports going to MongoDB. On any one of these specific ones, we can get very good detail on the network latency, application latency, response times, so forth. And we can also visualize this into a ladder diagram. So client versus server, where the time is getting taken up. And also, again, the expert analysis on the right-hand side. So the retransmissions. So you can get very good level of detail, as much as you would on an on-premise capability, leveraging this LiveWire in AWS. And just to put it back into context, just going back to this view here. So we were looking at the Mongo application in Oregon coming from the Austin site. But we can also heuristically see across the entire network where there's application issues. So here it will actually pick up from the routers or LiveWire any current real-time application performance issues and be able to show that, and specifically packet loss, jitter, delay, or other information here as well. So yeah, having one platform view that can see on-premises and cloud is actually pretty important for quicker troubleshooting. So going back to the geo view, we'll look at a couple of use cases related to security in the cloud. So back to our Oregon site, just drilling down more into detail here again. So we see the warning that we saw earlier, but looking at the devices, just look at our VPC, it'll actually show you information about the flow denied and created, like we were talking about earlier. So the AWS flow log has fields that indicate if the security group policy denied or allowed that particular flow. So this field is sent out, and you can use this to look at it in our platform. But you can also get these types of events from firewall devices as well. So you can actually run firewall type reports with the flow denied created information and run it across your firewalls as well as your VPCs to get information related to security incidents. So this provides very good detail about the different traffic that might be denied or created. And you can also get a real-time view of that. So I'm just going to switch to the topology view here. So this is the AWS Oregon VPC, and this will update as the flow logs come in, and it will actually show you the various subnets that's connected to that VPC. So there's a couple public ones, local, internet gateway, VGW, but the interesting one is actually things like rejected. So if you wanted to see traffic that we're getting rejected, we can watch this or filter on this and look specifically for information related to that. And we can run reports on that as well. So this will give you a real-time view of what's happening. Going back to the web user interface, as you're troubleshooting incident response and you see certain flows that you're interested in, you can go from here to our AWS LiveWire instance and go down to the packet level. So here again, you can hit the peak. Wherever you see the peak, you can use that to go down into our live peak capabilities, and it'll bring up the search with the various parameters, and you can narrow down the search if you wanted to as well. And we'll kick that off. And then we can look at more specific details about that search. So you could look at the networks, the applications in more detail, but really the packet level. And you can use this to filter on specific things and look for particular incident response. And it will also translate things into client server. So if there's specific, like a botnet controller that you identified and you want to see the exact communication that's happening, you can use this to look at that. You can look at very specific flows if you're interested. And also generate peer map. So this is all the traffic that's being seen by our AWS Livewire packet analytics. Create a peer diagram of which IP addresses are communicating to whom. And you can look at specific ones of interest, like if this guy's of more interest, you can focus and look specifically at that and get more details and make a filter and just look at those selected packets, for example. So it makes it very interesting and easier to look at incident response at the packet level using this capability as well. I think that's it for the demo. I hope this was useful. We can provide you more information, and we have capabilities for trials that you can use to try it out on your system as well. But yeah, I think the key things that we wanted to show was cloud monitoring, how to do it on premises and also in the cloud, how to leverage the flow logs and APIs from the cloud context, but mapping it so that you can make sense of it from an on-premise perspective. And then using it for application performance and also for security incident response. Okay, thank you very much.
Thanks, John. That was great. With that, I think we're going to pause here for some questions. I see some questions have come in from the audience. So the first one is, which cloud platforms do you support?
Okay, for the platforms, we support AWS and Azure, and we'll be supporting Google Cloud Platform as well. So those are coming. But natively, our LiveAX, our system can actually run in all three. But the cloud monitoring piece, it's Azure and AWS and GCP is coming.
Thanks, that's great. Here's another question for you. How long do you keep the flow log information from AWS?
Yeah, that's a good question. So how we set the system up is we store the flow log in S3 initially. So that's a setting in, for example, AWS or Azure. And Azure would be like a blob. But from there, we would be continuously polling that flow log that's stored in S3 and bring it into our system. So once we read that, you can actually delete the storage in S3, and it'll be stored within the LiveAX system. And at that point, you can keep it as long as you want. So it really depends on how much storage you've allocated for the cloud monitoring piece on your LiveAX system. And then, yeah, we keep it in a pretty compact format. So you can keep, weeks, months, you can even keep it for a year if you wanted to.
Oh, that's great. So here is another good question. Do you only monitor traffic from EC2 using Flowlog or packets?
So from EC2, basically how the flow logs and log information happens in AWS and Azure is as there's application traffic that hits a VNet or a VPC, that gets logged, for example. And EC2 is one set of services that would generate a flow log, but it could be anything to be clear. So for example, if you have RDS or a database service that connects to a VPC, that would generate flow log as well as an EC2. or if you create like an S3 endpoint in a VPC, those will generate flow log. So as long as you specify on a VPC that you want to generate flow log, and you can set this at the VPC level or at an ENI level or the network interface level, but that triggers the generation of a flow log. So yeah, you have pretty good flexibility in seeing all the traffic, not just EC2. So for example, if you have a transit gateway, typically those have a endpoint attachment, and you can have the flow logs generated for that. On the reverse side of it, on the packets, for example, you have to mirror traffic from EC2 or other services into our live wire analytics capability. So you have to specifically send that traffic to our analytics capability. So it's not as easy or flexible as a VPC where you just turn it on. But with the packets, you're getting much more detailed data and a bigger, you're going to consume a lot more space as well because you're getting the entire packet.
Thanks, John. So in that answer, you touched on transit gateways. Can you monitor traffic on a transit gateway?
Yeah, so that's an interesting question. So transit gateway natively doesn't have any flow log support. I suspect at some point, AWS would provide that. But when you create a transit gateway, you create different ways to connect to it. So transit gateway is like a very flexible and scalable way to connect different regions or different VPCs. And one of the things you typically do is create a transit gateway endpoint into a VPC. So like I mentioned, points connecting to VPCs, you can turn on flow logs, so you can see what's going in and out of a transit gateway from particular VPC, that's all connecting to our transit gateway. On the reverse side of the transit gateway, you're probably going to connect that from on-premises. So, whether it's your data center or colo. So since we have on-premises monitoring capability, you can see traffic that would be sent and received from a transit gateway. So yeah, we're waiting for more cloud native telemetry directly from the transit gateway. But today you can see what's getting sent in and out of a transit gateway.
That was very helpful. Thank you. Here is another question. Would you be able to identify if an application performance issue is simply because the circuit purchased from your internet provider does not have sufficient bandwidth, or when that bandwidth has been exceeded?
Oh, good question. So it kind of depends on if you're looking at it from an on-premises or cloud perspective. But yes, we can. One of the key capabilities we have is being able to do a path analysis of that application, and we can actually track things like drops that happen from a portion that you sent to from the monitoring portion that we received it on. So for example, that's called multi-segment analysis, but we can stitch together packet analytics from on-premise as the application is getting sent. And we can also pick it up on the AWS side. So we can tell you exactly which packets got received, sent, which got dropped. So that's pretty helpful. For the insufficient bandwidth, since we can monitor all the flows going in and out of a particular service provider from on-premises or for example, VPC connecting to an IGW or a VPN gateway, you can see if you're hitting the limits of the bandwidth capacity of that particular provider, for example. So you'll probably see if you're exceeding the bandwidth, performance issues across multiple applications. So that's kind of a good indicator is if a single application is dropping packets or having issues, it's probably not necessarily insufficient bandwidth. But if you see from the flow perspective or from the interface bandwidth utilization hitting those limits, and you have multiple applications that are having performance issues, you're probably hitting some kind of limit of that service provider link.
Excellent. So I think we have one more question here before we end this. Do you need two systems to monitor on-premise and cloud?
That's a good question. You don't. You can have a single platform to do that. But we provide a very flexible way to extend that visibility. So you can put the main LiveNX system on premises, and many of our customers do that. And they extend that into the cloud by, we provide something we call a node. They'll run on an EC2 in AWS or Azure, and they'll do the local polling of like the S3 and do the AWS CloudWatch API calls. And then that would actually send the traffic, the analytics back to the on-premise LiveNX system. But we also have customers that run the entire system in the cloud. So you can run the whole LiveNX system entirely in AWS or Azure as well. So you have pretty good flexibility, and we do have very large enterprise customers. They'll deploy, a LiveNX centrally, but nodes in the cloud, but also nodes into, other data centers that they have globally. So it has a very flexible and scalable way to deploy and monitor, large network footprints for our customers.
Thanks, John. So with that, how we can help you going forward, you can certainly take a moment to review this session again or share it with a colleague. You could also request a one-on-one LiveNX demo session, and I know that our team would be happy to support you in that. And then you can also check out the additional resources in the resource tab. And you certainly don't want to miss our next hackathon series, which will be focused on SD-WAN beginning next month. Thank you, everyone. Have a great day.